This is a balloon attached to the top of the pressure sensor test rig. If I turn it on its side, you can see the rest of the rig, and you'll notice that the balloon is sitting on top of this connection here, and the rig is all holding together. Now, if the pressure increases, it'll blow the rig apart because there's nothing holding it together like that. So you may need to put elastic bands around this part of it in order to get a better integrity when you're doing your tests. I'll take the balloon off there. I'll take this piece out of the other end. Now these components all go together. These pipe caps have got number 16 elastic bands on them, which allows them to fit into the end of this coupling and produce an airtight seal. So I can remove that. When you're setting this up, it's important to get the elastic band fairly close to the edge of the cap so that when you push it in, it rolls right in and forms a good seal. This cap is the same as the other one, except it's got some added fittings here to attach the balloon. And it's got this sensor wiring running in through the top. Inside the cap, we see a BMP pressure sensor with the wires connected to it, and they come out to these connections here, which you can then connect to your Arduino. At the other end, this cap has 4 holes in it of various sizes, and they've been countersunk a little bit just to smooth off the edges. On the outside, I've put a piece of Scotch Magic tape so that it seals up those holes so no air comes through. Later on, I can open 1 hole, 2 holes, 3 holes, or 4 holes, depending on how much flow I want to let out. This is the main component. This is a PVC pipe coupling, and it's got a pressure transducer mounted on the side here. This is a PX137 differential pressure transducer, and there's some wiring coming from it. Black and red for a power supply, and green and white will produce really low voltage output signals. This is essentially a strain gauge bridge like the one you used on the load cell, and you hook it up the same way. Inside here, you can see there's one of the ports of the pressure transducer. There's the other port. They're on opposite sides of this flat diaphragm that's inside. So here's the system with the balloon inflated. I've got my finger over the hole in the diaphragm down there, so there's no air coming out. And I've got a nice airtight seal between the cap and the coupling. And I can read the pressure from this transducer. I can also read the pressure from the transducer that's inside the cap. And that should give me some steady pressure information for both transducers. If I move my finger off the hole a little bit, the balloon will deflate, and that'll give me some information about how the pressure behaves as the balloon is deflating. I should still see the same pressure registering on both transducers.